Hey Pixelers, Michael Howden here. Now, imagine this. You're on a project for multiple years. You get to the final hurdle. You got a few months left before the major deadline that all of the shareholders have been talking about, and you've had all of these demos showing off and being very proud about what you're doing, to finally being told your application is not ready for production. The whole project must be delayed until major security requirements are met. Now, that sounds like a nightmare, and I had a similar situation like that a few years ago. Basically, what happened, big project, big ambitions, but we never took into account security right at the beginning of the flow. We started to take it seriously later on in the project. However, by that point, you have such a big backlog of security things to go through that the problem is it's hard to convince the developers, the project owners, the project managers to take your requests seriously because, when you tell people, hey, you're using all of these old libraries, you're going to have to redo a serious amount of your code base, they're just going to think you're wasting their time. Now, that's a horrible place to be because you know what's going to happen. You get to the end of the project, just like I said, and then suddenly everything has to be pushed back until it's actually ready for production. Now, this is the concept we call shifting left, because in the example I gave you, that means you're doing security on the right-hand side of your development cycle. Now, that may be confusing, but if you imagine your average Kanban workflow, let me show you 1 second. If you can imagine your average Kanban workflow, it's in multiple lanes like this, right? And you might have planning, you might have building, you're probably going to have testing, deployment, whatever it is, whatever flow your organization has decided. And these things are all going to flow naturally from one to the other. Now, normally in a unmature organization, you tend to find that people do all of their security concerns on this side here. Or alternatively, which you should never do, you do your security concerns after going to production down here, maybe 6 months down the road, right? That's horrible. You should never do that. The concept of shifting left is moving your requirements to decide on security all the way to the beginning. And that means all the way back in planning, because you might think that security starts with building. I can assure you it does not. It starts all the way back at planning. A lot of the times, even before the developers even know a feature or a change or a project has to be done. Right? So this is something that the project managers should be concerned of right from the beginning. So if we look at the waterfall definition of a project, the whole thing might become a bit clearer because it steps back a bit to see the whole project. Normally in waterfall, you start with your requirements right at the beginning up here. And that leads down into design, into implementation, into verification, into maintenance, right? The normal water flow design. If we think about shifting left, it becomes more obvious in this example that what we mean is starting security all the way back when we define the project's requirements. All the way at the beginning. What data is meant to be secure? What systems need to be secure? What's the risk of if a certain system is compromised, right? What's the attack vector that if someone gets into this part of the system, that then they can move on to another part of the system? All of these things should be taken into account right at the beginning, because ultimately you don't know how to secure something if you don't know what you're securing. What are the impacts of what you're securing, right? Ultimately, if there's no impacts, if there's no risk associated to something, then does it even need to be secured at all, right? We don't have to overcomplicate the solutions we provide. We should understand what it is we are trying to defend. And obviously, that is a business concern. So the project managers should be thinking about this right at the beginning of a project. Now, obviously, this can be a bit wishful thinking because not all project managers really understand the complexity of security and why it is so important to spend so many resources on this problem. So usually you have to tackle the cultural issue first, which is even further left than even getting requirements. Because the cultural issues that need to be addressed include things like 1, having ownership. Security should be the responsibility of everyone. This isn't just something for the security department to do. So there should be a cooperative experience in this endeavor. Two, we should break down the silos that exist in quite a lot of enterprise organizations. So I've seen quite a lot of organizations like this. This isn't just one or two, this is quite a handful, where you'll have your security team and no one wants to talk to them. And a large part of the reason why no one wants to talk to them is because you know, as soon as you talk to them, they're going to give you problems, right? So this also, this isn't just people bringing in the security team into these conversations as early as possible. This is the security team treating this as an experience of cooperation, right? Because no one's going to bring you into these conversations if you start tearing apart what they're doing, right? I mean, why bring in that aggravation? We can just pretend everything's secure, right? You know, why bring in the security guys? This has to be a cooperative experience where everyone's on board and enjoys working with each other. And a large part of that is the security people actually assisting with the solution, right? Because it's easy to come in there and go, you guys are doing a terrible job, right? No. Come in there and say, look, I'm going to help you out. Let's see what we can do together to make this work, right? I'm going to help you structure the work you need to do, organize the issues listed. I might even help you with the implementation to fix them, right? This is a cooperative experience. We're all in this together, right? We're not in silos. That's a key thing to understand. And obviously, once you've done that, it makes it very easy to do the next key point, which is to bring in security people and people who have this expertise early as possible, which therefore resolves the issue I mentioned when it comes to project managers not understanding which things should be considered important when they're clarifying the scope of a project, right? So number three, you're looking at early involvement of your security department. So early involvement, right? Really important to bring people in, because if you don't, you know, you're going to be running your project like a headless chicken. And one of my favorite mindsets that I see in so many organizations is actually assuming that your system is vulnerable. I tend to find that the organizations that have the best security are the organizations where people are primarily humble, right? Because you get some people who are, oh no, you know, my thing's impervious, it can never be broken into, right? Which when people have this mindset, you never properly figure out how to mitigate problems, right? Because people have this mindset, you know, that what they do is God's gift to the earth. They always assume, well, how am I going to get broken into anyway? So let's just keep everything open once people that makes no sense, right? What you need to do is you need to have an assumption that people will break in. As soon as you have the assumption that your system will be compromised, it makes it a lot easier to build a solution which, if someone did get in, they wouldn't be able to jump onto other systems or services, you know, do a traversal attack, move laterally, and subsequently, because you may assume people might come in, you may also put more effort into alerting and auditing systems and also procedures in order to lock down those systems when someone breaks in. So you have the playbooks and procedures in place to really bring your system back into compliance, right? So number four, I would say fundamentally is assuming people break in, right? Assuming a breach, let's put it like that, right? It's a good mindset to have. Assuming your system not only can be breached, but probably has been breached, right? How can we do this in practice, right? I just spoke a bunch of theory to you. So how do you practically do this, especially like in the context of, say, a Kubernetes cluster or your cloud environment? How do you practically shift left, right? So the first thing, obviously, is you need to understand what things fundamentally need to be secured. Now, in some organizations, you may draw up a risk assessment chart, right? So you might have, it's a little chart like this, and you know, you'll put things into different blocks. And fundamentally, on one axis, you have the likelihood of something happening, and on the other axis, you have the impacts if it happens. So you can assess your situation, so you understand which things very clearly are the most important things to protect, right? But this theory is still beyond the role of the average engineer, right? Because what I just mentioned there, that's for the project managers to do. Once it falls into your lap as an engineer, a key thing is to start thinking your pipelines as not just tools to deploy, but tools to ensure compliance. What that often means for me is still running your CI/CD pipelines on development branches. That doesn't necessarily mean that the container built or whatever the artifact is actually stored somewhere or deployed somewhere. You can skip that whole step. You can keep it to just the building and the testing. So people, when they're working locally and they just push their changes, they can get that instant feedback whether or not what they're doing is secure. Now, you can also go as far as obviously running scripts on people's machines locally, but in my experience, whenever you tell someone, hey, please test this whenever you make a change or every so often, people always find a way of somehow forgetting to do it. We can continuously test whenever someone makes a Git change on their branch, various key factors like, do their manifests for, say, Kubernetes have any misconfigurations in them? Is there any known vulnerabilities in their code, like CVEs that they're writing, right? Maybe in their dependencies, maybe they've recently updated the dependency and the new one they've pulled in has a vulnerability. Maybe in the container that's being built, because, there may be base layer dependencies for that container that may be out of date. That's really common. People very rarely update their containers. Or alternatively, just because we're shifting left doesn't mean we forget everything on the right. Shifting left may be a bit of a confusing term because, by definition, if you shift left, you're implying there's nothing still on the right, right? So when we shift left, we still want to keep everything on the right. Now, what that means is still have your continuous testing and production, right? So your developers can get instant feedback, whether or not it's through Slack, email, maybe some sort of operations reporting tool like Ops Genie can tell people, hey, a security vulnerability has been detected in production, in staging, in this system, in that system, right? So we can continuously test that the system is exactly meeting our requirements and expectations. Now, I hope this has given you a brief introduction to the idea of shifting left and why it's so important. I was just on this project, I just got off this project where alternatively, we did do this, right? So right at the beginning, we were bringing in relevant stakeholders, people into the meetings and asking them very directly, hey, what's important, right? What's the risk if this thing gets compromised? Is this actually worthy of putting a budget on it? When you bring in people right at the beginning, it's very easy to get budget approval. At the end, it's difficult because people have been promising something for 2 to 3 years at that point. And then when you tell them, hey, we need all this extra budget right at the end, you got problems. But when you do it right at the beginning, people understand. It can be sometimes easy to bring people in when there's no consequence to just saying, hey, that sounds good. This is actually what's important. Let's get this all hashed out and documented. And in this example, we got to the end of the project and everything there was no requirements. There was no security to just suddenly implement. It was just ready for production. And that is such a calming place to be. Because in this project I had a few years ago, we still had to keep our original deadline, meaning a mad rush in the past month or 2 months of fixing, patching, debugging, and coming up with a solution as quickly as possible, which I highly don't recommend. Anytime you hear people using the word security and quickly in the same sentence, is usually a message for disaster. Thank you for checking out this video. In the description, we're going to have a link to the white paper we've been working on to help companies understand how to secure Kubernetes when you have developers all over the world. So it's securing your workflows for remote first teams, because this is a problem I'm seeing so often right now when people are struggling to make sure that their engineers can test things on their development clusters, make sure they can access production securely while being remote, right? How do you solve that problem? So we're working on this white paper. If you go to the page now, you can submit your contact information so we can send you a copy when it is ready. Anyway, thank you so much, and I hope you guys have a lovely day. Cheers.